All right, we're going to talk about our second conic section, which is an ellipse. And remember, this is whenever, if I would have my cone, right, this would be my cone here with this as my base, I would slice through it like this. And so I would have, more of a slanted circle, which is called an ellipse. If we were in elementary, you might call this an oval, but we're in upper level math here, so the technical definition of this is an ellipse, but you can kind of think of it like an oval. The definition of this is an ellipse is a set of all points so that the sum of the distances between two fixed points or your foci is constant. So right now we have lots of different points on my vertex, on my ellipse. And vertex is going to be one of the points that we talk about here in a second. So if you want to pause this video and you like to use a lot of color, I would get out some highlighters, colored pencils, markers, whatever. You don't have to have it colored. That's totally fine. I will end up giving you guys kind of color copies of all of these once we finish them. So once we go through all four conic sections, I'll give you like a nice little paper for all of this. But if you want yours to look nice now, that's totally fine. So let's just go ahead and kind of start with what were those two fixed points that I was talking about? Well, we were talking about these points right here. So these are your focus points. We give that the letter C. So anytime I'm talking about C, that is my focus point. Plurally, those are foci. So again, these would be your focus points. Now they can be anywhere in between this point and this point and this point. So they can float anywhere. They could be right here, could be right here, could be right here. It just kind of depends on the equation, okay? But foci are in between your center. So we do know that center. That is consistent with a circle. Remember our circle, we only had a center and then we had the radius and that was it. Well, this is going to be different, right? Because I obviously have one kind of side of my circle that's a little bit longer than the other to give it that ellipse or more oval shape. So my center is still the same. That is still H comma K. So your foci are going to be between your center and these 2 points right here. And we do have these as notated here. So we're going to call this your vertex. And I'm even going to color these in pink a little bit more. So these are your vertex points or your vertices, plural. And we give those the distance between your center and the vertex points. We call that distance A. Now notice that this distance is longer than the distance from the center to these 2 points. Now that is always going to be the same. So we're always going to say that A is the larger distance. So that is key. This is where people kind of messed up last year. We always say that A is the larger number. Okay, it's that larger distance, that longer distance from vertex to vertex. This is important because we are going to call these other 2 points something different. These 2 points from my center to kind of that shorter side is my co-vertex. Okay, so those are not vertex points. So if you use the word vertex to describe these 2 right here, that is wrong. They are co-vertex or co-vertices. So we use the letter B to describe the length from co-vertex to the center and then from the center to the co-vertex. So we use the letter B to describe that distance. So that is this diagram. I'll even fill in this side length here. A. Okay, so that's what we have going on now. So we have we have distance A that is from center to vertex. We also have my distance B that is from co-vertex to the center. I also just have points, a location. That is my focus point. We call that the letter C. My center is still represented as HK. A is always the larger distance going across your ellipse. B is always the smaller distance. And then the final kind of bit of terminology that you will want to have memorized for this, because again, you will need all of those things memorized, but no reason to panic yet. Like I said, I'm going to give us a nice little, sheet that kind of has us filling this stuff out over and over again. You can kind of memorize it. Your major axis is the larger one. So your major axis is going to be 2 times A. So this entire distance across is considered your major axis. So again, that is the larger distance always. Now, it doesn't always have to go straight across, right? You can have an ellipse that's maybe something like this, where the larger distance is up and down. That's totally fine. A is just always your larger distance. Your minor, and I remember that because it's major. We're going to say that's major, so that's going to be larger. Your minor axis is going to be the entire distance across for 2b here. So this entire distance across is your minor axis. To me, this makes sense, right? Major axis is the larger one. The minor axis is the smaller distance across. And so we want to have all of those things memorized by the time we get to the test, but we have plenty of time. Okay, so let's actually talk about how do we graph these? What are my equations? What are my differences? What are some other things I need to know? So my major axis being horizontal, what does that mean? So that means if the major axis or the larger distance is horizontal, meaning we're going across. So it may be helpful to draw a shape. So that larger distance is a horizontal line, okay? Which we know horizontal lines have zero slope. So that would be major axis is horizontal. Look at this type of equation. It is very similar to my circle. We have x minus h squared, y minus k squared, but we now see that fraction piece come in. So that distance a is on the bottom here, and notice that this, because I'm running along the x-axis, so maybe let's even make another note here. Because I'm running that major axis along the x-axis, my larger number, because we know that the larger number is that a value, and my a value is always associated with my major axis. So that larger value here should be under the x if your major axis is horizontal, because we're running along the x-axis, right? We're moving left or right. So if my major axis, or that larger distance between my two vertex points, if that is running horizontally, then you're going to see your a value underneath the x. We also always have to have my equation equal to 1, and that will come in handy later on. Okay, so now let's talk about what if my major axis is vertical. So that's going to look something like this. So now I kind of have that ellipse. Now my major axis, or the longer distance, is running up and down, or now it's running along the y-axis, right? We're moving up and down. So notice the difference. The only thing that is different about this equation from the first one is that my a squared is now underneath the y. And maybe I'll even color coordinate that over here too. That is, again, because if my major axis is always associated with the value of a, this is always going to be your larger number. It is underneath the y because we are running vertically. We are going along the y-axis. Again, it is equal to 1. All right, we also have kind of a take on the Pythagorean theorem, but it's not, and we will kind of formalize this when I come back. I don't want to do all this in the video because I know I'm not here. I'm trying to just give us a brief overview, but this equation is going to be useful to find any missing value. Like, let's say you're not given all the values of a, b, and c. You don't know your distance a, you don't know your distance b, you don't know your location c. Then you can use this formula, c squared equals a squared minus b squared. Again, this is not the Pythagorean theorem. This is only used for an ellipse, okay? You will find that as we move through the rest of these conic sections, all of these equations are very, very similar. So it's easy to get lost, which is why I'm trying to give us visuals and helpful tricks right now, because trust me, it's going to get harder. Okay, so let's go ahead and graph a couple, and then we'll do some of those word problems, and then we'll call it good. So the first one here, the first thing that you need to do is identify what is your A, your B, and you have to find your C, because I'm not given any sort of information about that. I just will only be able to ever find my A, my B, because look at this equation, right? I have nothing to do with C in either of those equations. I got to find that on my own. Okay, so first step is recognizing what is the larger number. My larger number is always the A value. Okay, so this is the larger number. Notice how it's underneath the x. Okay, so we can kind of look back at this one as my kind of baseline. So a squared is what is underneath my x in that problem. My b squared then is underneath the y. And so we know my shape is going to look something like this. I'm going to have a larger length horizontally than vertically. So again, this is my a squared value. So if I'm just trying to find a, I would need to take the square root of 81, which is 9. Again, don't worry about positive or negative. We're talking about distance here. So it really isn't going to do much, right? Distance is always positive. So then this means that 25 has to be my b squared. And so again, that's my b squared. So I would need to take the square root of 25, which is just 5. I can now find c by using the formula c squared equals a squared minus b squared. So we can say c squared equals, and here's the nice part, I already know what a squared is, 81 minus 25. So we get c squared equals the square root of 56. For the sake of time, I'm going to go ahead and simplify all of these roots for us very quickly. You can do this on your own, but you should get 2 root 14. So c, again, is a location. A and B are distances. The only thing that I really need to know now is my center, okay? So I didn't point this out really when I talked about this the first time, but it's because it's the same as the circle. Your center is your HK, so I don't really need to go over that too much more. We did that with our circles, so center is HK. Well, I don't even have any number behind my X or my Y in parentheses, so that means my center is 0, 0. Makes it pretty easy for us. So here's how we graph. Now that I've figured out my A, my B, my C, and my center, I can graph my points. So if my center is at 0, 0, I can start right here. And that A value is 9. Again, let's look at what my ellipse was. From my center to vertex is a distance of A. I just found A to be 9, meaning from my center, I'm going 9 spaces this way and 9 spaces this way, to the left and to the right. Why am I moving 9 spaces to the left and to the right? Look at where this is under. This is under the X, so we are moving along the X-axis, or therefore left and right, okay? So I'm going to go 9 spaces to the left, 9 spaces to the right. There we go. Now I can do the same thing for my B. My B value is underneath the Y squared, meaning that's going to be movement up and down. So if we also look back at my ellipse, this distance from center to co-vertex is B. Center from co-vertex is B, up and down. So I'm going to do the same thing. So I can go up 5 spaces, and then I can go down 5 spaces. And now I can graph my shape. So I can kind of fill that in to the best of my ability here. Yours may look weird. I have my iPad, so I have a little bit of an advantage again. Okay, good enough. All right. You do not have to graph C. Okay, you could if you wanted to, but again, notice how C is just a point. It's not a part of my actual line. Okay, this is the actual shape that we make. You could graph C. I'm not going to make us, again, I don't really want us to type in 2 root 14. It'll be a decimal. You could, but you don't have to. Okay, but I do still want you to find C. I want you to know that it is important, but we do not have to graph it. It is it's a point that doesn't really exist on this ellipse. It's just, and we'll get to this more at the end of the notes today, but it's more of like a special point that, well, we'll get there. It's just kind of a special point, but it's not actually on the line, if that makes sense. Okay, number 2. So I'm going to go a little bit faster here because I know this is already going to be a long video, and I apologize. So number 2. 64 is my larger number. That's where my head goes first. 64 is my larger number. Therefore, that is the A squared. So your A is always your major axis, or the more distance. And look at where my A is now. Now it's under the Y. So I'm going to see some sort of shape like this, where I'm going to see more of a distance up and down. So if my A squared is 64, then I could take the square root of that to get 8. If my B squared, that means this has to be B squared, is 16, I take the square root of that, and I get 4. And so then I can quickly use my formula here. I get C squared equals A squared minus B squared. So I get C squared equals 64 minus 16, which is the 48. So the square root of 48 becomes 4 root 3. Again, I'm going through that very, very fast. I'm hoping we remember how to break down our roots. Okay, so now I can graph this one. So again, it's important to find your center, right? We got to know where we got to start here. So to find my center, I want to look at this right here. What's really important is you do not tell me that your center is 5, -2. Please do not do that. We do the opposite. -5, comma, +2 will be my center because that formula has those built-in negatives. So I'm going to go to the right, or sorry, left, 1, 2, 3, 4, 5, up, 1, 2. So here would be my center. And now my A value. That is no longer distance moving to the left or to the right. It is now distance along the y-axis because that A is underneath the y. So I want to go up 8 spaces and down 8 spaces. So I'm going to go up 8 and I'm going to go down 8. I'm then going to go to the left and to the right 4 spaces because that is underneath my x. So that would be movement to the left and to the right. So I can go 4 to the right, 4 to the left. Now I can graph my ellipse here, and there would be my answer. That looks terrible, so if yours looks like that too, that's fine. Okay, last one here. What's really important to notice about this one is you may be thinking, where is my denominator, right? The whole point of this is that I have a denominator, so I definitely need to do something about that. Well, look at what's going on here. I have this equal to 64. I cannot have that. I have to have my equation equal to 1. So the question becomes, well, how do I turn a 64 into a 1? Well, I can divide everything by 64 and go from there. So then I can reduce these fractions. And so I get, sorry, this is Miss Jones walking into my house right now and her laughing. I think only a couple of them know who you are. Okay, so 4/64 is going to reduce to 1/16. So I'm going to keep that here. And then 16/64 is going to reduce to 1/4. So you want to make sure that you can reduce this down so that way you have no coefficient in front of my parentheses like this. So just kind of reduce like normal again, right? If you need to use your calculator to reduce those fractions, that's totally fine, but we want to reduce those down. You should always have a coefficient of 1 right here. Okay, so now this looks exactly like a problem that we can do. Again, I'll kind of quickly go through this process. So I want to look at what is my larger number. My larger number is 16, and so therefore that is my a squared. So if my a squared is 16, I can square root that to get an a value of 4. That causes this to be my b squared, so the square root of 4 is 2. I could then use the formula c squared equals a squared minus b squared to find that point c. So c squared is equal to 16 minus 4, which is 12. So the square root of 12 simplifies to 2 root 3. Again, I'm hoping we can do that on our own. And now I can graph. So my center, looking at those h and k values, similar to the circle, would be, don't tell me -3, +1, tell me that it's 3, -1, right? We're doing the opposite of what's in the parentheses. And so when I graph that, I am going over 3, down 1. There's my center. And for the final time here, hopefully we've gotten the hang of it on this third time. If my A is underneath the X, that means I'm moving along the X-axis. So I'm moving left and right 4 spaces. So I'm going to go 4 spaces to the right, 4 spaces to the left. Then that means since my B is underneath the Y, that means we're moving along the Y-axis. So I'm going to go up 2, and I'm going to go down 2, and that finishes my shape. Maybe my pen just died. So that is great. So you can finish graphing that one out on your own. I'm also going to break this video into 2 parts so I can charge this pen. And I'll give this as your bonus opportunity. I just finished the Baylor and Clemson game, which was very exciting. So tell me who your March Madness bracket winner is for a bonus point. If you don't have a March Madness bracket, then just tell me who you think will win. Just take a guess. Ask one of your neighbors. All right, the next video you'll have to click over in Google Classroom once I get my pen and iPad charged because I'm also at 14%. So we'll take a little break.